Picture this. You're the pilot in command of a Bombardier Q400. You are navigating straight through severe weather. Lightning is flashing across the windshield. Rain is absolutely hammering the fuselage, and it's bumpy. Suddenly, a massive gust hits, and you naturally attempt to bank the aircraft to compensate. But the control yoke, it's completely locked. I mean, it is solid. The aircraft isn't banking at all. You are caught in a terrifying roll jam. And in this exact moment, hesitation is just not an option. Your survival depends entirely on muscle memory, highly precise communication, and the flawless execution of an emergency checklist.
Hey everyone, and welcome to today's Explainer. Today, we're stepping right into the simulated cockpit of that Bombardier Q400 to break down exactly how flight crews handle what is literally one of aviation's most critical emergencies, the roll jam. We're going to decode the exact procedural flight path that takes a crew from a moment of sheer, heart-pounding mechanical terror all the way back to a safe, controlled landing.
So consider this our pre-flight briefing. Here's our agenda for today. First, identifying the roll jam. Second, disconnect and gain control. Third, running the jam checklist. Fourth, what to do if the right control wheel is free. And fifth, what to do if the left control wheel is free. All right, let's get right into it. Section 1, identifying the roll jam in those critical first seconds.
Okay, so we're back in that storm. The yoke will not move. Let's dive into the step-by-step sequence to fix it. The pilot flying instantly calls out roll jam to alert the rest of the cockpit. Next, they immediately disconnect the autopilot. Then the pilot flying calls out roll disconnect and physically pulls the roll disconnect handle, rotating it exactly 90 degrees. Now, to help you remember this rapid-fire sequence, think of the JDR rule. Jam, disconnect, rotate. It's a second-by-second immediate action response that every single Bombardier Q400 pilot flying must have completely memorized. Now take a look at the hardware itself. Notice this yellow and black striped roll disc handle. This isn't just some digital button you lightly tap. This requires a deliberate physical action. Pulling and rotating this handle exactly 90 degrees physically separates the left and right roll control networks. By doing this, the pilots are intentionally isolating the jam side of the controls so that at least one of them can regain authority over the ailerons and spoilers. It is a literal mechanical override that saves lives.
Moving right along to Section 2, disconnect and gain control, basically establishing command in the cockpit. So once that handle is rotated 90 degrees and the control yokes are severed from each other, we have a brand new problem. Who actually has the working controls? Well, this brings us to a super strict protocol of crew resource management, or CRM. It's not a free-for-all up there. Both pilots will now attempt to control the aircraft, but they must do it one at a time, strictly guided by the pilot flying. The pilot who discovers they actually have the free working control yoke will definitively call out, "I have control." The other pilot, the pilot monitoring, must acknowledge and confirm that by replying, "You have control." This verbal handshake is absolutely crucial. It prevents conflicting inputs and establishes total clarity in what is obviously a chaotic environment.
Up next, Section 3, running the jam checklist for systematic survival.
Okay, control is established, but the emergency is far from over. The pilot flying calls for the roll jam checklist, and the pilot monitoring begins to execute it. Now, the crucial point here is this explicit caution right from that checklist. With the roll disc handle pulled, the autopilot must not be engaged. I really want to stress this. You have deliberately severed the mechanical linkage of the flight controls. If you try to hand the aircraft back to the autopilot now, the computer will lack the full mechanical authority it expects, potentially throwing the plane into an unrecoverable state. So, hand flying, it is now mandatory. At this point, we face a literal fork in the road based on which side of the cockpit actually has the working yoke. To understand the physical sensations the pilots are going to experience, let me give you a quick memory trick. Right regular, left light. If the right control wheel is free, roll control will be degraded, sure, but the physical forces required to move the yoke will actually feel fairly normal or regular. But if the left control wheel is the free one, the roll control forces will be unusually low or light. So remember, right regular, left light. Let's look closer at that first scenario. Section 4, right control wheel free, and managing those normal forces. If we find ourselves in the scenario where the right control wheel is free to move, meaning the co-pilot side is working, the pilot monitoring has to watch this exact panel on the screen. If these specific switch lights, spoiler 1 and spoiler 2 push off, illuminate continuously, the crew must take immediate action. The checklist dictates that they must push both of these illuminated switch lights to the off position.
Breaking down the instrumentation a bit further here, the pilots need to anticipate specific caution lights so they aren't startled by them later on. The SPLR outboard or spoiler outboard caution light is going to illuminate when the aircraft drops below 150 knots indicated airspeed. Plus, the roll SPLR NBD, that's inboard ground, and roll SPLR out BD, outboard ground, caution lights are completely expected to illuminate the exact moment the aircraft touches down on landing. Knowing this sequence beforehand prevents the crew from panicking and thinking a brand new emergency has just started.
But what about the other side? Let's check out Section 5, left control wheel free and avoiding overcontrol. So, what if the jam was actually on the right side, meaning the left control wheel, the captain's side, is the one that breaks free? Remember our memory trick from earlier, right regular, left light. Because the left wheel connects differently to the spoiler networks, the roll control forces are going to be surprisingly low. The yoke will feel incredibly sensitive in the pilot's hands. The checklist explicitly warns the pilot here. Delicate handling is required, and the tendency to over-control the aircraft should be strictly avoided. Honestly, a heavy hand right here could cause the aircraft to snap roll, which is the last thing we want.
There is also a critical speed restriction to manage in this scenario. If the pilot finds that roll control is just inadequate while they have flaps 5, 10, or 15 selected, there is a hard, unbreakable rule. Airspeed must be reduced to a maximum of 165 knots. 165 knots is the absolute ceiling here. Slowing the aircraft down reduces the aerodynamic forces at play, which gives that super sensitive left control wheel a way better chance of managing the plane's attitude.
Okay, as we approach the runway, the checklists provide some highly specific landing considerations based on which wheel we're actually using. Look at this comparison. For both scenarios, the crew absolutely must seek out an airport with minimum crosswind and minimum turbulence. You definitely do not want to fight the weather with half a control system, right? But notice the flaps. We can call this trick the flap rule, higher for left. If the right wheel is free, you land using flap 10 or 15. But if that left wheel is free, you have to use wider, higher flap ranges, flap 15 or 35. So the flaps are set, the runway is in sight, the aircraft touches down, and those expected ground caution lights we talked about, they illuminate right on cue. The pilot monitoring calls out the final 2 words of the procedure, checklist complete. What began as a terrifying loss of control in a severe storm has just been systematically dismantled by procedure, rigorous training, and memory, bringing the Q400 and everyone on board to a completely safe and successful resolution.
It's truly fascinating when you pull back the curtain like this. We've just walked through one specific emergency for one specific aircraft. But it leaves you with a pretty profound realization. If a single jammed mechanism requires such a perfectly synchronized, highly memorized human response to overcome, what other invisible safety nets are pilots deploying, practicing, and perfecting for your everyday flights? The level of rigorous training flight crews undergo to keep us safe is absolutely incredible. Thanks for joining me on this explainer. Keep learning, and I'll catch you next time.